Alright guys, so we're going to continue with part 2 of benzene, that is the chemical properties of benzene. So kita akan tengok what is electrophilic aromatic substitution. We're gonna look at the reactions that benzene can undergo, which is nitration, halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Okay, so itu untuk benzene punya reaction. Okay, and then you have reaction of alkyl benzene. That means that you have a benzene with an alkyl group attached to it. Alright, so those derivatives will undergo oxidation and halogenation. Alright, so first things first, we're going to look at electrophilic aromatic substitution. Okay, awak dah tahu what is electrophilic substitution. So electrophilic substitution is when, okay, let's say here you have your nucleophile, which is your benzene, because benzene is very electron rich. Okay, and then you have your electrophile. Whatever electrophile, dia akan berubah-ubah mengikut reaction apa. Okay, so you're going to substitute your hydrogen with this electrophile. So ni masuk, ni keluar. Okay, and then you will get your benzene ring with an electrophile and H plus yang kena buang tu. Okay, kena buang. Alright, so that is electrophilic aromatic substitution. Aromatic sebab dia adalah an aromatic compound lah. Okay, and then you have, for electrophilic aromatic substitution, you have 3 steps that you have to remember, which is the formation of an electrophile, formation of uranium ion, and then finally loss of proton atau deprotonation. Nak buang proton tu, okay, untuk dapat balik your aromatic compound. Alright, okay, so the first step, okay, is the only step that you have to really remember, the formation of electrophile, because your electrophiles will be different for each reaction. Okay, for step 2 and step 3, they are typically the same. Okay, just that awak punya electrophile tu berbeza, tapi awak punya pergerakan curly arrow will be the same lah for those reactions. Okay, alright, so let's look at step 2 and step 3 tu macam mana nampak dia. So formation of uranium ion is when you have your benzene ring and electrophile here. So your benzene ring, this double bond, nucleophile will attack your electrophile. Okay, and then you will form this structure. Okay, you have to show that since you lost a double bond here, you lost this electron, this carbon lost its electron, so dia ada carbocation ion at this carbon. Okay, and then awak punya electrophile kat sini. Okay, so electrophile ni dengan hydrogen ni tak berubah sepanjang step 2 ni. Okay, so sekarang kita akan tunjuk resonance structures of your uranium ion. This ion here is called uranium ion. Okay, bila awak ada carbocation ion ni, so kita akan tunjuk these 3 structures of uranium ions. So this double bond can move to this single bond, can travel here, delocalize, okay, supaya carbon ni cukup elektron. So we will get this structure pula. Okay, double bond kat sini. So sekarang this carbon yang tak cukup elektron, so ada this carbocation ion here, and then this carbon pula, this electron pair will move here, delocalize. Alright, so basically awak kena tunjuk 3 uranium ions punya Kekule structures, saya salah pronounce. Okay, so itu je. Okay, bila awak practice, ini sangatlah senang. And then you're going to take any of these uranium ions. Okay, saya ambil the first uranium ion untuk buat step 3. Okay, once kita dah ada uranium ion, we will be using whatever nucleophile that we have, okay, to capture this hydrogen, because we want a double bond here, and we have a carbocation ion here. So maksudnya this carbocation ion wants electrons. So in order to remove this, buang this carbocation ion, untuk satisfy dia, kita kena letak elektron kat sini. So mana datang, Daripada ni lah kita kena deprotonate hydrogen. Deprotonate this uranium ion. And then this bond will close here. Okay. So awak dapat balik your benzene ring. Now you have your electrophile attached to your carbon of benzene ring. Alright. And then ni awak dapat balik lah whatever awak form dengan hydrogen tu. Alright. Okay. Alright. Did I show you this? So ini basically contoh for electrophilic aromatic substitution lah. You know that benzene is nucleophile. Okay, electron rich. Lepas tu chlorine ni akan jadi awak punya electrophile lah. Okay. Nanti awak ganti awak punya H dengan electrophile. Okay. So now in this page it is the 4 electrophilic aromatic substitutions. Okay. That benzene can undergo. You have nitration, halogenation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. Okay, so you can see here for nitration, maksudnya daripada ada hydrogen here, you're going to substitute hydrogen with NO2. So in order to form NO2, you will be using this reagent with this condition, okay, with this temperature. Alright, so you will form NO2 by reacting these two acids together. Alright, so nanti kita tengok macam mana. And then you will form a byproduct of H2SO4 and your product is nitrobenzene. Okay, sebab ni nitro group, lepas tu ni benzene. So itu adalah nitration. Okay, second is halogenation, maksudnya this H will be substituted with any halogen lah. Selalunya awak guna Cl or Br. So jangan pandai-pandai lah nak guna yang lain, okay? In the presence, you're going to react your benzene with whatever halide molecule in the presence of a Lewis acid. Okay, so Lewis acid, dia punya function adalah untuk increase the polarity of your halogen molecule ni. Okay, supaya lebih senang untuk dia jadi living group atau electrophile yang bagus. Okay, so awak punya byproduct will be whatever HX. Okay, depending on what is your X lah. Okay, contohnya, okay, for halogenation, you can have chlorination to be specific. Maksudnya awak guna chlorine molecule in the presence of FeCl3 Lewis acid, or awak boleh juga guna AlCl3 Lewis acid. Okay, kena ada Lewis acid. So nampak sini, ni hydrogen ni kena ganti dengan Cl dah. And your byproduct is HCl. Alright. Okay, so awak dapat chlorobenzene when you undergo chlorination. Next halogenation is bromination. Maksudnya you are going to react your benzene with Br2 in the presence of FeBr3. So for bromination, you are only going to use FeBr3 Lewis acid. Okay, tak ada AlBr3. Okay, and you will get a bromobenzene. Okay, alright, so that's halogenation. And then you have, what is this? Friedel-Crafts alkylation. So Friedel-Crafts alkylation, you will be using an alkyl chloride molecule. React with alkyl chloride. Okay, in the presence of Lewis acid. So your R ni depends, it can rearrange. Maksudnya dia akan form a more stable carbocation depending on the structure of awak punya alkyl group lah. Okay, rearrangement apa? 1,2 hydride shift atau 1,2 methyl shift. Okay, so awak gantikan awak punya H ni dengan R. Okay, R group. So dapatlah alkyl benzene and your byproduct is HCl if you're using these reagents lah. Okay, alkylation maksudnya awak tambah alkyl group. Ganti dengan alkyl group. Okay. So, beza dia dengan Friedel-Crafts acylation is you are going to substitute your H with an acyl group. Okay, this is an acyl group. Okay, in the presence of Lewis acid. Okay, so instead of R, awak akan dapat this C double bond O. Okay, acyl group. Okay, so tapi dia macam lebih kurang je, okay, dengan alkylation ni. Sebab kita guna method Friedel-Crafts yang agak sama. So, the type of acyl groups that you can have are acetal group. Okay. Acetal group. Here, you have an ethanoyl group. Sebab ada 2 carbon. Okay. Dia ada C double bond O attached to an R group. Okay. Or you can have a benzoyl group. Benzoyl group maksudnya awak ada benzene attached to your C double bond O. Okay. So those are the type of acyl groups that you can have lah. So watch out. Alright. Here is the function of Lewis acid. So Lewis acids ni you will use, okay, because it can increase the polarity of your halogen molecule. Contohnya, you have ClCl here, okay. Kalau ClCl on its own, it is a non-polar molecule. But in the presence of FeCl3, your Lewis acid, you can form, okay, a positive charge halogen ion, okay, Br plus atau Cl plus. So right here we are going to form a Cl plus, okay. So bila dia Cl, okay, dia guna dia punya lone pair electron to attack your ion. Okay. Dia akan, it will have a positive charge. Okay. So this positive charge means that the Cl wants electrons. Therefore, nanti bila ada nucleophile attack, it will attack this chlorine supaya this electron pair in this bond here akan go to this Cl since dia nak electron. Okay. So basically it is making the chlorine atom right here more susceptible, more reactive, more vulnerable to nucleophile attack. Okay. Ini dia dah good electrophile dah, tapi sekarang it is a better electrophile, okay? Lebih baik. So that's why we use Lewis acids. Alright. Okay. So you have a few unusual reactions of benzene, okay? Kalau awak ada alkene, kan, bila awak undergo bromination, awak akan dapat Br, kan? Br, kan? Dekat awak punya double bond. Betul? Awak akan ada decolorization sebab awak punya bromine reddish brown color tu decolorize. Tapi when you have benzene, okay, and you do this reaction, bromination, there is no reaction. There is no addition of bromine. Okay, so therefore awak punya observation is no decolorization. Okay, sebab no reaction. Why? Because this benzene ring is very stable, so it will not undergo any addition reaction. Okay, benzene will usually undergo substitution reaction only. Okay, alright. So here we have an oxidation reaction. Kalau alkene, awak akan oxidize lah and potong double bond tu, betul tak? Okay, and then tambah O ke, lepas tu ada OH, dapat carboxylic acid atau aldehyde, kan? Tapi for benzene ring, you do not have any oxidation reaction. So no decolorization of your purple color potassium manganate ni. Okay, samalah sebab benzene ni very stable. Okay, so here, okay, kalau benzene kita try hydrogenate it, okay, boleh. Tapi it is a very slow process. Okay, it will react at high temperature and pressure. Slow addition of H2 at high temperature and pressure. So maksudnya boleh, tapi not likely lah. Kalau awak nak buat pun awak kena ada high temperature and pressure. Okay. So ini nak cakapnya yang benzene is not the same as alkene. Okay. Because benzene has extra stability due to the 6 pi electrons delocalization. Okay. Maksudnya dia boleh bergerak around awak punya ring tu. Elektron-elektron ni boleh bergerak. Itu membuatkan benzene ring awak sangat stable. Okay. So dia tak easily undergo addition reaction. Alright. Okay. Alright. So those are reactions of benzene. Okay. So now we are going to look at reactions of alkyl benzenes. So sidechain reactions of benzene derivatives. So contohnya, okay, kita akan tengok what if alkyl benzene undergoes oxidation. So right here we have an alkyl benzene. We call this alkyl benzene because ni awak ada benzene dengan alkyl group. So this is actually a toluene. Okay. So when it undergoes oxidation, okay, acidified potassium manganate, this reaction will give a benzoic acid. Okay, why is that? So ini awak punya alkyl benzene ni boleh undergo oxidation, okay, at this side chain. Okay, asalkan awak ada benzalic hydrogen. So yang hydrogen kuning yang saya highlight ni adalah, it's called benzalic hydrogen. Okay, so as long as you have a benzalic hydrogen, okay, the hydrogen attached to this carbon that is attached to this benzene ring, okay, so then you can have side chain reaction. Contohnya oxidation ni, dia akan ubah jadi COH. Okay, so macam ni juga bawah ni. Okay, awak tengok awak ada dua side chain dekat benzene ni. So in this side chain you have one, okay, benzalic hydrogen, and this here you have 3. So as long as you have a benzalic hydrogen, okay, then your substituent can undergo reaction. Okay, so ni dia tukar jadi COH. Alright, tapi benzene awak tak jadi apa-apa. Okay, benzene does not undergo the reaction. Okay, tapi the side chain boleh, asalkan ada benzalic hydrogen. Adakah this hydrogen dikira benzalic hydrogen? Is this a benzalic hydrogen? No. Okay, ini tak kira benzalic hydrogen. Okay, benzalic hydrogen is the hydrogen attached to the carbon that is directly attached to the benzene ring. Yang ni bukan directly attached to benzene ring, jadi ini kita tak panggil benzalic hydrogen. Okay, alright. Another side chain reaction that alkyl benzene can undergo is halogenation. Okay, so let's say here you have a toluene. So when you have Cl2 as your reagent with the presence of heat or light or UV, alright, it will undergo free radical substitution right here. Okay, okay, so basically awak gantikan awak punya hydrogen with Cl lah, substitute. Okay, with Cl free radical. Okay, okay, so itu ada dua je side chain reaction untuk alkyl benzene. Alright, okay.